Hello friends, I am Dr. Rajesh. I am again with you with my new video on central orbit. Now in this video we will discuss an important problem. This problem is very important from the examination point of view and very easy to understand. So you will be with me throughout the lecture, and I can assure you that you will be able to not only understand this problem but will also be just keep it with you as and when it is required. So this problem is very easy. So we will be first studying the statement of the problem, and the statement goes something like a particle moves with a central acceleration. So acceleration is given in this particular case. If we say acceleration is given, so this will be acceleration is given by mu by r square, and its projected velocity, this v is v at a distance r is equal to r. This is the given condition. Now we have to show that its path is rectangular hyperbola. If it will represent rectangular hyperbola, we will it will represent rectangular hyperbola if the projection is this particular angle, sine inverse this much. Okay, so we know that force is equal to mass into acceleration. So mass into mu r square. Okay, and mass is a constant quantity and mu is a constant, so that may be assumed as a new constant. Lambda is equal to m mu, where lambda is a new constant. This implies that f is equal to lambda r square, lambda r square. Okay, so this is the law of force, and this is the law of force in case of hyperbolic orbit, and you will refer to the article. In that case the velocity is given by, in case of hyperbolic orbit, velocity is given by 2 by r plus 1 by a, where here in particular we have taken constant as mu because it is given in the problem. Okay, so this is taken as mu. So if we take it as mu, so that is not going to make any difference. There it was lambda, so here it is mu because it is given in the problem. Okay, where 2a is the length of transverse axis. Now in case of hyperbola we have two axes, transverse axis and conjugate axis, and the figure of hyperbola is given as this one. In this you see this is the transverse axis, and this is a comma 0, this is minus a comma 0, so this length is 2a. So 2a is the length of the transverse axis, and this is the conjugate axis. Okay, in hyperbola we have two, transverse and conjugate axis. So this is the expression. We have already studied the expression for velocity in case of hyperbola, and when the force, low force is given by this particular much, so velocity is given by this one. So this is the given condition. This condition is given condition, and I am going to name this condition as 1 and name this law as 2 and this as 3. So next we are going to use the given condition, and the given condition is 1. Okay, and going to using condition 1 in 3. What is condition 1? V is equal to capital V when R is equal to R. So 3 implies capital V square is equal to mu 2 by R plus 1 by A. This implies that V square is equal to 2 mu R plus mu A. This implies that mu a is equal to v square minus 2 mu by a. So I'm going to name this equation as equation number 4. Okay, now next we see this figure. In this figure, this p is any point r theta on the curve, and this is the radius vector r. Okay, and this is the tangent drawn at point p. Fine, this is tangent drawn at point p, and this is making an angle psi. You have already studied it in the curvature section. Now I'm going to draw a perpendicular. I'm going to draw a perpendicular. So this is the perpendicular drawn, and this angle is 90 degree. Okay, and this is the length of the perpendicular p. Fine, so from triangle, if I say O P A, in triangle, this phi is angle between radius vector and tangent at P. In triangle O A P, we can see that OA upon OP is equal to sine phi. This implies that OA is P and OP is R is equal to sine phi. This implies that P is equal to R sine phi. Okay, so this implies that P is equal to R sine phi. We are given that when R is equal to R and it represents rectangular hyperbola, then alpha is angle of projection, that is phi is equal to alpha. So using in equation 5, we get P is equal to capital R sine alpha. Okay, and this you will name it as equation number 6. From the hyperbolic orbit article, we know that h is equal to root mu L, because there it was h is equal to root lambda L. When we derived the law of the force, then it was h is equal to root lambda L, but here we have taken mu instead of lambda because it is given in the problem. Mu is given, so it is our foundation that we cannot take anything other than the mu. So that is the, and here L is the length of semi latus rectum, which is given by b square by a. Therefore h is equal to mu b square by a square root, but here it is representing the rectangular hyperbola, and in case of rectangular hyperbola, b is equal to a, so this will cancel out. So this implies that h is equal to root mu a, and you are going to name it as equation number 7. We also know when path is given, when path is known or given, P dot V is equal to H. That expression we have already derived. So now I am going to put the values of here P is P and V is velocity and H is root mu A. This implies that from equation number 6 we can write that it is R sine alpha and multiplied by V is equal to root mu A. Root mu A. This implies that sine alpha is equal to root mu A upon VR. This is further equal to root mu root A upon VR. This is equal to root mu root A divided by VR and root mu. We have multiplied and divided by root mu in the numerator and denominator. So this will be further equal to mu VR root A by mu. So this implies that sine alpha mu VR. Now I am going to put the value of root A by mu from equation number 4. Now you will see the equation number 4 is mu by A is this one, V square minus 2 mu A. So I am going to use this particular equation. So I am going to put the value, and the value is 1 by, and value is of mu by A. This will be V square minus 2 mu by R using 4. So this implies that mu VR V square 2 mu by R raised to the power 1 by 2 is sine alpha, implies alpha is equal to sine inverse mu VR V square 2 mu R 1 by 2, and this was required to prove that angle of projection is this one. This is very important question from the examination point, and I feel that this question will be there in the examination this time. So you should thoroughly go through this question, and if you feel any problem you could ask me anytime. So this is all I have from this lecture, and this is Dr. Rajesh, and if you like the video, please like, subscribe, share and comment. So this is Dr. Rajesh saying you goodbye. Thank you very much for watching the video. Thank you very much, and very soon I will be with you with my next video. Till then, keep studying and patiently wait for my next video, and share your feedback with me through comment section. Thank you very much. This is Dr. Rajesh saying goodbye. Thank you.